This last video is for reviewers and for anyone who wants to check our work. Everything in this series reproduces from the public companion repository. 10 notebooks ordered by experiment. 9 of them run from cached artifacts at zero cost with no API keys. The 10th is the entry demo. It makes live calls, and with no key set, it falls back to an open weight rater, so it stays free too. The headline reproducers are notebooks 3 and 9. They rebuild the 25 rater panel and the hero figure from the committed per rater data. The authoritative source for every panel number is the panel 25 directory, regenerated deterministically by a single script with a pinned seed. If any older artifact disagrees, it carries a superseded banner pointing there. This is Notebook 1, the quick start. It runs the Experiment 1 headline end to end. Multi-provider consensus trait inference on Pride and Prejudice. 2 research questions. Can a consensus of LLMs infer ocean factors from literary text? And does consensus improve over the best single provider? Runtime is about 10 minutes on a free Colab instance, under 10 cents with the default models. And note the box at the bottom. No API keys, no problem. With no keys set, the notebook falls back to an open weight rater, Quen 2.5, answering the same probe prompts locally. Keys are optional. The setup cell clones the companion repository and installs dependencies, about 30 seconds in Colab, and a no-op if you run locally from the repo. Section 1 finds the data. The ground truth and the evidence packs ship inside the repository itself, no external download, and both paths report OK. Everything the notebook needs is pinned in the repo. Section 2 loads evidence packs for 5 main characters: Elizabeth, Darcy, Jane, Mr. Bennet, and Mr. Collins. Full book reproduction is a one-line change. Drop the main characters filter. Then, Section 3 runs the probe itself, each character rated against the same prompt the paper's consensus runner uses. Section 4 scores the run against ground truth. 4 metrics: profile accuracy as MAE, lower is better; profile accuracy as Pearson correlation; trait distinctiveness, how separable the characters are; and cross-model consistency, how much the providers agree. And here is the result table. 18 ground truth characters loaded, 5 scored. This particular run used the free open weight fallback, which is deliberately rough, a demo of the plumbing, not the paper's method. With provider keys, you get the paper's multi-provider consensus, M4, and the headline numbers come from notebooks 3 and 9, which run at $0 from cached artifacts. Notebook 2 is the Experiment 1 reproduction, organized research question by research question. Same setup cell as before. Clone, install, change into the notebooks directory. Every artifact it reads ships in the repository under the Method Bake-Off Artifacts folder, so the whole notebook runs at $0. Only pandas, NumPy, SciPy, and Matplotlib are required. First up, the leaderboard. 6 methods and the multi-provider consensus, M4, wins at a mean absolute error of 0.230, with the cheap regressor, M3, second at 0.262. Below it, the M3 leave one book out row, 0.312, the deployment-relevant generalization number the paper quotes. The forest plot cell renders the same table as Figure 1 in the paper. Research question 2 is where the paper's central methodological point lives. Do methodologically distinct methods agree under a strict Campbell-Fisk multi-trait multi-method test with an absolute monotrait floor of 0.30? That floor matters. It catches degenerate low-variance classifiers that the relaxed default test would falsely pass. Here are the numbers. The top pairs, consensus with regressor clear the floor at 0.83. But scan down. M2, the classifier, sits at a within-method heterotrait mean of 0.25, degenerate under the corrected test. Methods agreeing with each other is not the same thing as validity, which is why the next bar exists. Bar 3 asks whether the methods track an independent, crowd-rated label source, Open Psychometrics, 1.5 million raters, mapped to Ocean, on the 60 overlapping characters. Conscientiousness and neuroticism clear directly. Agreeableness fails both ways, and that failure is what motivates the HEXACO decomposition later in the notebook. Research question 4 checks whether the traits that fail bar 3 are just scale-shifted. 500 stratified train test splits show openness and extroversion recover under a 2-parameter linear calibration. Agreeableness does not. Its calibrated correlation interval still spans 0. The A failure is not a scale problem. Research question 5 is the decisive test for agreeableness. If no linear combination of all 4 methods can predict the external A label, the failure is at the construct level, not the method level. And that is what happens. A's ceiling correlation is 0.05, with a confidence interval spanning 0, while all 4 other factors clear the ceiling. LLMs and human crowds mean different things by agreeableness. Research question 6 rolls the 3 bars and the 2 diagnostics into one verdict per factor. C and N validate cleanly. O and E clear under calibration. A fails raw, fails calibrated, fails the ceiling. That verdict table is the paper's table 3. So, is the agreeableness failure a measurement bug? Research question 7 runs the HEXACO decomposition across 3 independent rater families, Anthropic, OpenAI, and Google. All 3 recover honesty humility from text with pairwise agreement around 0.8, and all 3 disagree with the external A label in the same way. The failure localizes to the label source's construct, not to text-based measurement. Research question 8 is the deployment table. M4 wins openness and agreeableness by statistically certified margins. For the other 3 factors, the top methods are tied, so the cheaper options are sufficient. Research question 9 reconciles a pre-registered refutation. The same probe architecture that scored 0.28 on one-turn dialogue lands at 0.633 on broader utterance corpora. The refutation was an input regime artifact, not an architectural failure. Research question 10 asks whether adding honesty, humility, and P scrambles downstream archetype assignment. The null is a proper joint permutation of the H and P columns, 10,000 reps. 53 of 60 characters keep their archetype, and the observed stability is indistinguishable from chance under the permutation null. The 7 movers are all literally defensible honesty axis cases. Both Buchanan's, King Claudius, Queen Gertrude. Each shifts in the direction HEXACO theory predicts. And the fairness control? On narrative role prediction tasks built from Ocean-derived labels, Ocean only beats the augmented vector, exactly the expected outcome on a test built from Ocean reference labels. No circular advantage claimed. Section 11 rules out prompt priming. Asking H and HEXACO agreeableness in separate prompts gives a higher correlation than asking them together, 0.87 versus 0.69. The factor purity gap is structural to the rater, not a prompt engineering artifact. Section 12 quantifies how much of the 3-family agreement could be a shared training corpus prior, bounding it against the within-provider test-retest ceiling. The answer? 10 to 30% of cross-rater variance is provider-independent, above what a fully shared prior would produce. That residual is necessary, but not sufficient evidence. A human rater HEXACO panel is what would attribute it, and the paper says so. Section 14 is the distillation. The whole multi-provider pipeline compressed into an embedding-only ridge regressor with 7 outputs. All 7 factors clear leave one book out generalization at roughly a 61 times cost reduction. And the spec block pins every training detail. 562 characters, 75 works, the alpha grid, and bootstrap confidence intervals. And the final section is the pre-registered head-to-head. Which factor vector should downstream work adopt? HEXACO, Ocean 6, or Ocean HP? The ranking is clean and monotonic. HEXACO clears all 18 monotrait cells. Ocean 6, 15. Ocean HP, 14. Ocean HP's failures all concentrate in the fused warmth cluster, which is the paper's construct story showing up one more time. Total cost to verify all of this from the cached artifacts, $0 and about 30 seconds. Notebook 3 is the paper's headline reproducer. The 25-rater HEXACO panel run at $0 from cached artifacts. Section 1 is the headline. The canonical mean absolute R between honesty-humility and HEXACO agreeableness is 0.75, falling to 0.30 on the synthetic characters, a mean drop of 0.447, with every one of the 25 raters decreasing. Section 2 breaks it out per model. Mean absolute R 0.752, and every family shows the fusion. Section 3 is the family clustering test, an intra-class correlation of 0.58. Raters cluster by who built them. And Section 4 stratifies by alignment regime, but regime is not separable from provider family here, which is why the contrast gets retracted. Section 5 is the load-bearing result. The per-rater synthetic minus canonical drop averages minus 0.447, about 3 times the pre-registered threshold. The verdict prints prior-driven. The fusion is retrieved from a memorized prior, not read from the text, and every rater moves the same direction. Seed stability is tiny at 0.05, and the headline survives Benjamini-Hochberg correction at a corrected p of 1 × 10 to the minus 7. The panel then expands to 28 rows for the retraction test, where the alignment regime contrast comes back collinear with provider family, and the likelihood ratio test gives p equals 0.78. The contrast is retracted as structurally untestable. The last cell reframes it as a retrieval share. Synthetic absolute R retains about 40% of the canonical value, so roughly 60% of the measured correlation is the retrieved prior. That is the catch, quantified. That is part 1. You have seen the instrument built and checked. 6 scoring methods across 75 works and 562 characters, and the 25 rater panel that carries the headline, rebuilt from committed data at $0. Part 2 is where it gets tested. Notebook 4 builds the synthetic characters the whole falsifier rests on. Notebook 5 maps the cache boundary and asks whether you can tell, before you rate, that a character is memorized. Notebook 6 rules out writing style. Notebook 7 pins the human anchor. Notebook 8 looks inside the network. And Notebook 10 runs the cheap regressor you would actually deploy. The repository link is in the description. The full 30-minute verification walk closes part 2.